Hey class, so this is a quick video intro for the notes for day 2 of unit 3. The topic is variation. So variation is going to be a type of word problem that we do in this unit. And there's 3 different types of variation that we're going to talk about. Okay, so there's direct variation. That's the first one. And you might see this kind of key term, y varies directly with x. That means as as x increases, y also increases. It's kind of like a positive slope. And then there's inverse variation where if x increases, y might decrease, or there is an inverse relationship there. Okay, and then there is, and if we see inverse variation, it'll say y varies inversely with x. And finally, if there's joint variation, then we have more than one variable present. And so we would say jointly with, for example, y varies jointly with x and w. There's more than one variable. And I will say that joint variation is going to be exactly like direct variation. So there's formulas that go with this. If y varies directly with x, the equation looks like this. Y equals k times x. Okay, we also call this proportional or directly proportional. Okay, so what is that k? That k is called a constant of proportionality. So it's basically just like the multiple of x that equates to y. So it's a number. It'll be like y equals 2x or y equals 5x. And it's a number that we have to solve for in every problem given some information, okay? So when we write our formula, I always say to put the k right away. Put the k right away. K right away. So you're gonna hear me say that, okay? And we do the k for inverse variation too. If we have y varies inversely with x, it looks like this. We put the k right away, but it's not k times x, it's k divided by x. That's our formula. So these vary inversely. And if we have a joint variation, there's just more than one variable. So if y varies jointly with x and w, it looks like this. Y equals, put the k right away, and then we have x and w. So it's a lot like direct variation because everything's being multiplied, okay? Now, in some things, some problems, it might say y varies directly with x and inversely with w. Okay, so if it says that, oh, there's a lot going on. So what I would do to write this equation is the following. Y varies directly means y equals. Put the k right away. If it varies directly with x, then it's being multiplied times x. And inversely with w, then you put everything over w. So whatever comes after the word inversely automatically will go to the bottom of a fraction. Okay, so hopefully that helps you guys understand some of these formulas and the way that we're going to come up with these formulas for the word problem. So I'm just going to go over example 1 with you, and then we will do the rest in class together. Example 1 says the pressure exerted by a certain liquid at a given point is proportional or varies directly to the depth of the point below the surface of the liquid. If the pressure is 20 meters below the surface, I'm sorry, I read that wrong. If the pressure 20 meters below the surface is 70 kilograms per centimeter squared, then find the constant of proportionality. Guys, this means solve for k, which is how we start all of these problems. You always have to find the value of k first, and then answer the question after that. What is the pressure exerted 40 meters below the surface? Wow, there's a lot going on, but this is what I know. Okay, the pressure exerted. Okay, so I'm going to put a little highlight there. Pressure exerted is proportional, means varies directly, okay, to the depth of the point. So really it's just to the depth that I care about. Okay, So I like to use the letters that kind of correspond here. So the pressure is proportional. The way you'll write that is the pressure, so I'm going to use P for pressure, is proportional or varies directly, means equals. Put the K right away. To the depth, so I'm going to use D for depth, okay? So it's proportional to the depth, and that's it, the depth below the surface. So this is the formula. The hardest part of all of these is going to be coming up with that formula, all right? So the second piece of information they give you should always help you find the K value. You should be able to plug in for every letter of your equation except for K, which is exactly what we're going to do now. So it says if the pressure 20 meters below the surface is 70 kilograms per centimeter squared. So this is actually kind of confusing. You have to read this really carefully. In fact, the first time I did this, I messed it up. The pressure 20 meters below the surface. So 20 meters below the surface, that's the depth. The pressure is 70 kilograms, so that's the pressure. Okay, so we're going to plug in 70 for pressure. The K is always staying a K for the beginning, and then we plug in the depth, okay? So now we are going to solve for K. So I'm just going to divide over that 20. And I like to leave it as a fraction, but you could leave it as a fraction or as a decimal. So 7 over 2 or 3.5. Okay, that's your K value. All right, so now we have to answer part B, and that's how all these questions are going to be. The first thing you're going to have to do is find the K value, and then you're going to have to answer an additional question, okay? So it says, what pressure is exerted 40 meters below the surface? So we're going to write the equation. The equation is P equals K times D, but now I know that K is 7 over 2. I could also just put 3.5, all right? And then times D. So this is the official equation, and it's asking what is the pressure 40 meters below. So I'm going to plug in 40 for D. So pressure equals 7 over 2 times 40. Okay, so then you just take your calculator, or you can do this in your head. You take 7 over 2 times 40, which is 140. And then I always look back at the original problem for the units. It's kilograms per centimeter squared. So the answer is 140 kilograms per centimeter squared. I am not picky about units, to be honest with you guys. So don't freak out if you forget to put your units. It's all good. That's the answer. So we're going to do more problems like this, but hopefully that is a good start to the notes. Thanks, guys.